I'm going to talk you through now one of the required practicals in the electricity topic. In this one, we look at current voltage graphs. Let me explain first of all what a current potential difference or current voltage graph is. So current goes up the y-axis and potential difference. That's why it's called current potential difference graph. So we've got voltage along the x-axis and current up the y-axis. So there's the origin in the corner there. So we could have some values on. So let's say I measured the potential difference across a component as being 4 volts and the current through it was 0.4 volts. I'd mark a point on that graph there, and then I could increase the potential difference to 8, measure the current, so say I got 0.8, and I'd mark a point there. Crucially, a little bit different from many graphs that you've done probably at all in science, is it's got negative axes. So we have a negative axis for the potential difference, so that's point goes down from 0 to -4 and -5 volts, etc. And then we've got a negative axis for the current, so we've got a negative current. That's because halfway through the practical you swap the terminals around on the power supply or the power pack or battery, and that'll give you a negative potential difference because it's in the opposite direction, which will make the current flow in the opposite direction. So that would be -2. So step by step, number one, you measure the potential difference across the component with a voltmeter. You then measure the current that's going through it with an ammeter. Potential difference is changed, so you change it and then you measure the current again, so you get different values. Keep doing that till you've got enough values to draw a graph, and then reverse the terminals to your battery so that you get a negative potential difference and then negative currents. And finally, you draw a graph like we've got there. So this is straight out of the specification. So the required practical is use circuit diagrams to construct appropriate circuits to investigate the IV, that's current voltage, characteristics of a variety of circuit elements, including filament lamp, diode and resistor. So there's 3 that we're going to do. First one that I'm going to do is the resistor at constant temperature. Then I'm going to do the filament lamp. Then I'm going to do the diode. Let's have a look at the apparatus that we're going to use. A battery or power pack. A variable resistor, that's so that we can alter the potential difference across the component. I've just put a resistor in to start with, so that would be part 1. And we need an ammeter. So all of those are joined up in series, so the current will go from your battery through the ammeter, then through your resistor we've got for part 1, and then the variable resistor and back to the battery. By changing the value of that variable resistor, we can get different values of potential difference. So there's something missing there. What I've got missing now is the voltmeter. The voltmeter needs to go across the component, so it's measuring the potential difference across the component that we're interested in. In this case, for part 1, it'll be the resistor. I'm going to start off with resistor at constant temperature. The circuits are going to be the same for all 3 that we look at. Power pack, out from the power pack into variable resistor. I can change the value of the resistance by sliding that along. That'll mean that I can have different potential differences across the resistor. Series circuit, round through the resistor, back through an ammeter, so I can measure the current. Need to measure the potential difference as well though, so remember the voltmeter has got to go across at the component that we're interested in. So it goes across either side there of the resistor. We can then take different values, first of all in the positive direction. I don't want to exceed that 4 volts there. If I get heating, I might damage that. It might potentially get dangerous, but also I'm looking at a resistor at constant temperature. I'm trying not to let this resistor get too hot, so I'm not going to do very high values. I've got my first reading here already. It's round about 1.04 volts. 1.04 volts. Current of, it's flicking between 0.11 and 0.10. I'm just going to make a call. I think it's on 0.11 more of the time, so I'm going to use that one. Now I'm going to increase the potential difference. I'm going to try and slide it up so I get 1.5, just so I get a range of readings. 1.2, 1.3, 1.4. If I can get it on 1.50, it'll make it slightly easier to plot. Oh, I've gone past now. Oh, right, I'll take that 1.50. 1.50 and a current of 0.15 amps. Couple more. I think this time, turn the power pack up as well. I'm looking to get round about, oh, it's almost there, 1.99, 2 volts. Excellent. 2.00, 0.21. I'll do one more and then it won't go any higher, so I'll just go up to 2.5 volts. 2.3, 0.4. Doesn't really matter, as long as you're getting a range of values. I'm just trying to make it slightly easier if you plot a graph. 2.50, 2.50, 0.26. All of those are positive values, so I'm going to add a positive there. Just when we're plotting the graph, because it's got positive and negative axes, just want to make sure it's nice and clear. If I switch it off so that we've got a potential difference of 0, we end up with a current of 0, no push, no flow. So I've got an extra reading there, that'll be in the origin. Now I need to get some negative values, so I need to reverse the way the current is flowing. The easiest way to do that, and if you explain this in the exam, just say you reverse the terminals on the power supply, or you reverse the polarity of the battery, or you swap the battery terminals around. Now when I switch it on, I've got minus sign, got a minus sign. So I'll do, try minus 1 if I can get, minus 1.04 and minus 0.11. You'll see that's the same values, the opposite way around, so it's not made any difference. Let's go up to 1.5. Minus 1.4, minus 1.5, minus 1.50, minus 0. It's flicking between 1.5 and 1.6, minus 0.15. Let's see if I can get it up to minus 2. I had to turn that up. Minus 2, it's almost there. Minus 2.03, minus 0.21, and the last one I need about minus 2.5. Minus 2.5. That'll do. Oh, nice. 2.50 minus 0.26. You'll see that the positive values for potential difference in current are pretty much identical to the negative values. That'll show itself in the graph, and it'll be the only one of the 3 where you do get that. All right, that's part 1 done. Here's the results then, in case you needed to do it and you've got time to do your graph. I've just summarised and take a picture of my results. And then if you've got time, you can use them. If not, I'm going to show you now how to do the graph.
plotted the current voltage graph for a resistor. So these are my positive numbers, so I've got 1 volt and 0.11 amps, 1.5 volts, 0.15, etc. So there's positive numbers there. And then when I reversed the potential difference, I've got the negative numbers there. Remember, it went through the origin. If I had no volts, I've got no amps, so I've got that point in the origin. So you can see that this line is directly proportional. So we say that the current is directly proportional to the potential difference. If I was to double the voltage from 1 to 2 volts, then the potential difference doubling will double the current as well. So it's directly proportional. And you always get that straight line for a resistor as long as the temperature remains constant. If it was a different resistor, if I put a resistor on there that had a bigger resistance value, it would have a smaller current for the same potential difference, so I'd end up with a line potentially like that one for a different resistor. It'd still be a straight line, it would just be lower down.
Part 2 then, filament bulb. Setup's the same, looks a bit complicated to the wires, but this is just a series circuit. Power pack, variable resistor to the bulb, back to the ammeter, back to the power pack. Voltmeter is measuring the potential difference across the bulb. Do the positive direction first, switch it on. Doesn't look like the bulb is on, but I know the bulb is conducting. We've got a potential difference across it and we've got a current flowing through it. If you look very carefully, I'm not sure how that's going to come out on the camera. There is a very, very faint glow in that bulb. Whether you'll be able to see it, I'll have to have a look later. That's just on. Give it a squeeze. I'm just trying to get it as 1.5 volts. I can put a much greater potential difference on this one. It'll take right up to 12. So 1.5, this is the positive direction, so it's plus 1. It's just changed a bit. Squeeze it back up. Fiddly. 1.50 and 0.92 amps, and we're in the positive direction, so I'll put the plus. Let's turn it up. I'll go up to, I think I'll go up to 3 volts, trying to get a bigger range this time. You can see it's glowing orange now, so 3 volts. Might be difficult to get it exact. I'm going to take that. Plus 3.00 volts, 1.30 plus 1.30 amps. Turn it up. I'll go to 4. Very sensitive. I'll take that, 3.97 plus 3.97, 1 plus 1.52 amps. I'll go up to 5.5 volts, as near as I can get it. Oh, I didn't, it went again. 5.48 plus 5.48, 1.82. That's up to 7. Plus 7 point, fluctuating a bit. I'll go 0.5 volts and plus 2.12 amps. I'll turn it up and do one more. That first. If I can get it to... I'll make this the last one and I'll go up to 9 volts. 9.08 plus 9.08, 2.43 amps. I switched off, let that cool down. I turn it down, I'm going to do the reverse direction. So remember, to do the reverse direction, we reverse the polarity of this power supply. I want to get it roughly the same, so I want minus 1.5. Minus 1 point, minus 1.48 and minus 0.96. Around about 3. See the bulb just lighting up now. Minus 3.07. Minus 1.37. I'm going to jump a bit just to speed it up. I'll go up to 5. Minus 5.05. Minus 1.78. Go up to about 7. Minus 7.03, minus 2.14, and then one more, go up to about minus 9. Minus 9.10 and minus 2.44 amps. There we go. Very similar values in the positive and negative direction, but this will be a different shape when we come to do that on the graph, as you'll see later. Your results for the filament bulb.
Plot the graph for the filament bulb. So these are the positive potential difference and positive current, and then when I reversed it, we've got the negative potential difference and the current flowing in the opposite direction. We can definitely see now it's not like the last graph where it's a straight line. It's not a straight line. If you're in doubt, get your eye down and look along the line and you'll see that we've got a curve like that. So I'm going to try and draw it freehand. So it's curving like that. Look at this. This is like a reverse image of it. Try and draw it like that. So we end up going through the origin and forming this sort of S shape. This happens because the resistance of the bulb is changing as the bulb gets hotter. So I'll label it there, the filament hotter, resistance increases, so it curves over. It's designed like that. It's designed to get hot, which means the resistance increases, which makes it hotter further still. And eventually you end up with it being very hot, about 5,000–6,000 degrees, which makes it white hot, which makes it a bulb. So this is a very distinctive curve. So if you see this curve going through the origin, that's a filament bulb.
Part 3 then is the diode. I've put a light emitting diode in there. Could have used a normal diode. Remember, these are designed to allow current to flow in one direction. LED, same thing, but it lights up at the same time. What I've struggled with is to get the power pack to have a low enough voltage to start with. The resistance is quite low on this, so what I've just got a cell, and I'm going to use this for the first reading because it's a little bit lower. So if we've got 0 potential difference, we'll get 0 current. So we'll do the forward directions first. So just with this cell, we've got 0.83 potential difference. and you'll notice there's no current flowing there. 0.83 volts, no amps, plus 0.83, 0.00. So there's not enough potential difference to set the current flowing. Let's go to the power pack now. I've got it turned down as low as I can get it for this first one, with that resistance as big as I can get it. Notice now it's lit up. 1.7, so that's plus 1.70 volts, 0.05 amps. I'll just do one, maybe two more. Been a little bit careful, they're quite fragile, they don't take much current. 2.24, so it's still plus 2.24. Oh, it's gone up to 2.5 now. 2.5 and 0.17. See, the current's gone up quite a lot in that step. Still positive. We'll do one more. 1.28 and 0.46. Right, something went wrong with that one. I'm going to leave that. I'm just going to do the reverse direction. So the reverse direction, I'll do the first reverse direction. So instead of having it like that, reverse the polarity. This time the current will flow the opposite way. Minus 0.83 and no current. Right, and then for the rest, we've still got no current flowing. This is because the diode is designed to only let current flow in a forward direction. So when we end up doing the graph of the current voltage characteristic, we'll get something on that side. But on the other side, it's not going to be symmetrical. It's the only one of the graphs that's not the same forward and backwards, because we don't get a current flowing. So we'll plot that out and we see what we get. Final one then, there's the results for the diode. I'll do the graph for you now so you can see what it looks like. Finally then, graph for the diode. These points up here when I had a positive potential difference. So when I had a positive potential difference, I did have a current flowing through it. But what I did notice was I didn't get any current flowing until about here, so I needed some amount of potential difference in order for it to get going. Try and draw a best fit then. Rises up like that, but along here stays on the origin because we've got no current flowing. So the diode is different in the positive direction and the reverse direction. You don't get any current flowing in the reverse direction, so it's quite obvious when you see it on an exam paper because you've got nothing down here. It just sticks on that x-axis there. So that's the diode. Current only flows in one direction.